Assalamu alaikum everyone. How are you? Yes, how is everyone? Assalamu alaikum. Saad, Basit, Fahad.
Walaikum salam, sir. I'm fine. What about you?
I'm good. I'm good. I'm feeling better now. The previous past days I had a cold. I'm much better. I'm also having lunch. So only ignore if you hear any chewing sound. Also, Shafe. Shafe, are you in the Google Classroom?
Yes, sir.
No? Shafe, send me your email. Send it in this chat even. You can send it on WhatsApp or in this chat, doesn't matter. I'll add you on to Google Classroom. Hmm. And who else? Zoya. Zoya, are you in the Google Classroom?
No.
Hmm. Zoya, you can do the same as well. What you may call, send me your email and I'll add you on to Google Classroom. Guys, just give me a moment. I just realized that a lot of these students are newer. They have not been in my classes before. Hmm. Shafi, I've sent you an invitation. Kindly check. And Zoya, could you please also send your email as well? Okay, so I could add you onto the Google Classroom where we have everything. Nonetheless, let's move forward. So what's going to happen is that, for example, we're going to continue on where, just give me a moment, guys. All right, guys. In yesterday's class, what we did was that mm, we completed off with the last thing that I did was when the base is equal to one, what will happen to it? When we were doing rules of indices. Today we'll inshallah finish them off. And one of the last remaining rules of indices are what will happen when the power is a negative number. So we've seen that, when the power is a negative number is equal to a negative number. What will happen when the power itself is equal to a negative number? So we've seen throughout, you guys probably will notice this trend that whenever we've discussed it, we've always talked about, having there's been no sort of mention of, ever there being a power with a negative, a base with a negative power. We've seen power is equal to one, we've seen power is equal to zero, and but this can be a possibility, right? Your powers could be negative as well, because I stated in the beginning that the powers are they're completely they're irrespective of whatever base you use. You could have any power at any times. Keeping this in mind, we're going to take some sort of precautions with this one, because as we did previously, now we're going to do some extra step that there could exist. What is that going to be? Let's continue. So first of all, when the power is equal to a negative number, you want to take reciprocal of whatever the base is. Take reciprocal of the base. Change the sign of the power. Change the sign and of the power. Oops, to here. Take reciprocal of the base, change the sign of the power. Then simply whatever power you guys have, you're going to solve accordingly. Regardless of whatever power you have, you're just simply going to solve accordingly. One thing that you need to know is that, we never solve a negative power. We're always trying to convert it to a positive one. How we're going to do that? Let's see. So, for example, let's just say that, a generic example at first. So, for example, let's say that a raised to the power minus x. Now, this is simply going to be, you have to take reciprocal. So, how will I take reciprocal? That is just going to be that I have to flip the fraction. So, it's 1 over a, and the power is over a, not over the entire thing. So, it's going to be x. Now, what I've done is that I've simply changed the sign of the power, and I'm just going to simply, solve it now. That's the only difference I've done. And on a side note, what would we consider being a reciprocal? So, for example, if I say that a over b, now if I write this as b over a, that means that I've taken reciprocal. Flipping of a fraction. So you sort of change positions. Get guys? Anything that anyone doesn't get? Hopefully this is clear. Moving on, let's if you and for example, if there is no number, like you know, there could be a case where you have no denominator, sorry. So you have no denominator, so it's just like a. So obviously the reciprocal of a is going to be 1 over a. Why? Because even when there's no number below your denominator or numerator, you're always going to have 1 there nonetheless. So that is why that you flip the fraction. That is very simple. Let's look at a few examples. And I saw an example above here. Why don't I do that one? So for example, this one, let's do this one. 15 over 37 minus 37. So my example states what? My example states that it was 15 over negative minus negative 37. Simply what you're going to do is that you're going to take the reciprocal. Now you're going to take the reciprocal is just going to be 1 over 15. And obviously, keep this in mind that the power is over the numerator alone. It's over 15 alone. So it's going to travel with 15. If you take 15 into the denominator, the power is going to travel with. If you take 15 back up to the numerator, the power is going to travel again. So it's going to be 37, and it's going to be 1 over 15 raised to the power 37, whatever the answer is. Now, if I want to convert it back up, like for example, I can even switch it up. If I take it back up, it's again going to do the switcheroo. 15 raised to the power minus 37. So, back and forth, back and forth. What we're just trying to say is that, if you move the position of your base, the sign of your power changes. That is what we're trying to tell you. Keeping all of this in mind, let's look at another example. Now, another example could be that, maybe we have, let's say, 4 over 3 raised to the power minus 2. Could be a case. Now, consider the example that the power, the negative 2 power is over the entire fraction. Like it's on top of 4 over 3. It's not simply over 4 nor simply over 3. So that means that individually these powers are negative 4 raised to the power minus 2 over it's 3 raised to the power negative 2. That could be the case, right? That's the most possible explanation. Considering this, now, if that is the case, I've told you that whatever your power is, wherever your base is, you have to take reciprocal. So now what's going to happen? That my denominator is going to become 4 squared. I took 4 down. I took the reciprocal of 4. And what is the reciprocal of 3? It's going to come up. It's going to be like this. And your final answer will probably be like 9 over 16. Is this clear? Kindly do make sure that whatever base you have or whatever wherever your base is, you just switch its place. So if it's in the denominator, make sure it goes into the numerator. If it's in the numerator, make sure it goes into the denominator. Considering that we have the power as a negative number. All right. So that is good. Now, what's going to happen is next up, and also this was brought to my attention in the previous class is that you guys are not stopping me to write this down. So you guys can write this down or you guys can even take screenshots. It's up to you. I'll give you time. So anyone who has not written this down from yesterday's class or has yet to take a screenshot, you guys can let me know when I need to move forward. All right. Okay. Yes. Are you guys done with this? Shall I move forward? Everyone done? I hope so. If there's anyone who hasn't taken a screenshot or written this down, let me know. Usually, what happens is that I would try to give you guys time to write down stuff. But sometimes it may happen that I'm in such a hurry that I go through with the flow. So do stop me wherever you've not documented anything down, because the notes are perfectly the notes will be perfectly available on Google Classroom as well. But whatever you're writing in class is going to be rather more beneficial because of the fact that it's going through your eyes or it's going under your eyes at the exact moment. So anything that you do not understand at this exact moment, you can ask me as well. All right. Hopefully this is clear. If there's any questions, let me know. And now we're going to move on to our next topic, which is surds. All right, guys. Can anyone describe to me what do you, or all right, what's the first word that comes to your mind when I say the word surds? Yes. Yes, Amdan. What comes to your mind when I say the word surd?
Mr. Number.
A number? All right. That's good. And what about you, Zoya? What comes to your mind when I say the word surd? Zoya, can you hear me?
Yes.
Yeah, Zoya. What sort of light bulb goes off when I say surds?
Um,
Mm, the light
rationalization.
rational what? Sorry?
Rationalization.
Rationalization. Very well done. Excellent. Oh, yes. That's one aspect of using surds. Wow. And what about you, Shafir? What comes to your mind when I say the word surds? Yes, Shafir. Can you hear me?
Yes, sir. Like values in a square root that cannot be further simplified.
Very well done. Yes. Essentially, all of you are right in the sense that, and Assalamu alaikum, Hayan, how are you? You're a bit late, Hayan. All right, because now you're late, Hayan, you have to answer. What comes to your mind when I say the word surds? Yes, Hayan.
Something that cannot be further simplified.
Okay, okay. All right. So yes, all of you are more or less you're accurate in terms of telling us that what surds are. The entire crux of this conversation is that surds in are simply roots. If I put them up in like very easy lingo, they're going to be that you're simply you've gotten roots. So for example, there's a surd and it's going to have some sort of power and it's going to have some sort of base as well. All right. So what's going to happen now is that simply this is your base again. And this right here is your surd. Oh, wait. Let me fully identify. This is your surd or your root. So what's going to take place over here? That this right here is again your base, the number upon which the surd is acting. And this right here is your surd. And writing this to get all together, this entire sort of what you may call form of writing this down is known as writing down in surd form. All right. And if I were to explain what surds are, like to put a perspective around them, there's just you can call roots, under root, whatever, square root, cube root, root of four, stuff of that sort. So their roots, they give you technically whatever. What does this mean is that whatever number that you might have gone any process of index notation or whatever the number has been derived from, it is these are going to take us back to its root. What's the root number of this? All right. And one more thing that you need to know is that your base in the search cannot be equal to base cannot be equal to what you may call negative number. All right. So your base can, and this sign actually resembles that something is not equal. So your base is not going to be is not equal to a negative number, such that let's just say that it can never be less than zero. That cannot happen. So apart from this, now obviously we have certain rules as well. So let's look at these rules of search. First off, you have what you may say the relationship between the search form and the index form. All right. So it can be both ways to go. So for example, if something is written in search form, there's a certain, and the x over here denotes like, it could be any power of the surd as well. Like it could be a square root, a cube root, whatever it is. And your base is equal to a. Now, this is interchangeable. This is interchangeable how? That this can be written down into this can be displayed in index form. And this is already being displayed in surd form. So from the index form that it is being displayed in, you can convert it right back to your surd form. How you're going to do that? Let's see. The base is going to remain the same. And now you're trying to understand that if there's a root on top of a base, and if I write it in terms of powers, what is the actual power equivalent? What's the power equivalent to the root that you have? Simply what you're going to do is take whole square. Oh, take whole power and put 1 over x. So whatever the power of your root is on acting on top of the base, when you're writing it down in index form, you're just going to take this power of the root as the denominator to the fraction of the power in the index form. And the fraction is going to be always be 1 over whatever the power was. The numerator has to be always 1. So this is an interchangeable relationship between your index form and your surd form. Let's see. So this is your surd form. This is your index form. All right. And then these we can clearly say that they have an interchangeable relationship between themselves. Is this fair, guys? So you can go back and forth. Now, if I look at it in terms of an example, so let's say that, under root 7, under fourth root, and the base is 7. So the power of the root is 4, the base is 7. Now, if let's just say that it's becoming a bit too difficult for me to solve, or it's a bit, there's some sort of simplification that needs to be done. And these are usually paper 2 questions. All of the questions that we've done above are also, this topic is predominantly paper 2. Why is it predominantly paper 2? Because obviously in paper 4, you're allowed your calculator. So if you're going to be, if you're allowed your calculator, the examiner is not going to give you something as easy as this to simplify or stuff of that sort. So these are much more popular questions in paper um, 2. And what you're going to have is that this can be equal to 7 raised to the power 1 over 4. Is this clear, guys? Simply, every single time, I don't think I need to do any more questions. Obviously, we'll do them in the end. But regarding this, any other example questions, they're always going to follow the same method, which is what? That the power of your surd, whatever power it held, is going to act as the denominator to 1 in the index form if you write it like that. Clear? Hopefully this is clear. Any issues, let me know. Otherwise, we're going to move on to something I think Zoya told us, rationalization. Now, this is extremely important because we see this a lot as well, and this has links with trigonometry. A lot of students confuse rationalization, the process itself, when they see 2 or 3 rationalized values. So let's just look into this rationalization. Your surds, one thing that what we're trying to say is that surds cannot exist in the denominator. That's our only concern. We do not care about anything else. We're only concerned with the fact that surds cannot exist in the denominator. Now, for example, they can exist in the denominator. We just don't want them to. That's the idea behind it. So, for example, let's just say that, um, so there's 1 over under root 7. 1 over under root 7. This is going to be equal to what? Now, this is existing in the denominator and there's nothing wrong with it. But in order to rationalize it, in order to use it in some sort of mathematic function, I need to make sure that it does not exist in the denominator. I need to rationalize it. How do we do that? What we're simply going to do is we're going to take our same surd in the denominator and we're going to multiply it with itself. Now, obviously, you guys know the drill that whenever we multiply something with itself in a fraction, you have to do it with both. You have to do it with the same with the numerator and the denominator in order to make sure that the balance of the fraction remains intact. So how will you do that? Is that simply what you're going to do is just a moment, yes. So simply what you're going to do is you're going to multiply in order to maintain the balance of the equation that's it. Multiply with whatever you're multiplying with, you just have to make sure that you're doing it on both ends, denominator and numerator. What does that do? Now, the top part can be salvaged. We already know what the top part looks like. I can say that 1 times under root 7 is obviously under root 7. But in order to better understand what your bottom, or you can say your denominator looks like, we need some, you know, guidance from the, what you may call, um, indices rules. So what's going to happen is under root 7 times under root 7. Can I write this as, we already know that, your, what you may call, that is what's happening in the denominator. Now we already know that if I want to write it in index form, how am I going to write it? I'm going to write it as 7 raised to the power 1 over 2. Multiply by 7 raised to the power 1 over 2. Why? Because it's square root. Now, keeping this in mind, what's going to happen now? What simply is going to happen now is that you're going to have, like, if 7, the bases are same and are being multiplied, powers are being added. Obviously, if the bases are same and are being multiplied, powers are added. So what is going to happen now? 7 raised to the power 1 over 2 plus 1 over 2. Half times half, half plus half is 1. So 7 raised to the power 1. So what's going to happen in the end is that your final sort of answer is going to become 7. Now, this is one reasonable explanation for this. Another one could be that because this is 7 under root 7 times under root 7, you can also write this as what you may call, mhm, you can also write this as under root 7 whole squared, right? Because it's being multiplied to itself twice. And what does that do is that it's going to simply cancel out these roots. And that is going to happen for everything. This is just an explanation I'm giving you as to why you're getting this answer. Any root that you might introduce, it can be cube root, whatever it is, you just need to multiply the root with itself and you'll get the answer as now the root sort of shifts in the denominator and shifts in the numerator and you're replaced by the base itself in the what you may call denominator. A perfect representation of this could be that, for example, if you write down in your calculators 1 over under root 2, sometimes the calculator is going to give the same answer as under root 2 over 2 or under root 3 over 3 for 1 over under root 3. That is going to happen every single time on your calculator, because your calculator is going to show you the rational answers. All right. Keeping this in mind, now we can know how to rationalize something. So if I were to write down a very general, generic version of this, it can be done so like this. And obviously, you're going to multiply with under root a both the numerator, and kindly make sure that you're doing it with the numerator as well. Otherwise, you'll get no mark. And this is going to be the root a over a. Hopefully, this is clear. If there's anyone who doesn't get this, let me know. All right.
Sir, can the example be simplified further?
The example be simplified further. How will you do that? Sorry. Give me an
Sir,
example.
I'm asking if there's a possibility.
Yes, obviously. Like, for example, if this was being multiplied to 7. Okay. 7 times 1 over under root 7 can actually be written as under root 7. Why? Because this can be rationalized. And if I rationalize this, what's going to happen? It's going to be 7 times under root 7 over 7. 7, 7 cancels out. Yes, that can be the case. Sorry. Obviously, it depends on the question. And like I said before, these are usually paper 2 questions. Although it doesn't really, this is not a very favorite topic of the examiner. You might just have to, you just need to know this step. You might have to do it in order to make something look like the other. For example, sometimes the examiner tells you to write something down, but he wants it in some sort of shape, or he wants it in some sort of specific form that he has labeled already. Keeping this in mind, because that is the case, you're obviously going to have to look for alternative versions of writing down the same thing. So this is equal to this. All right, so this happens as well. Although it's really rare that he asks you to rationalize. Like he specifically tells you. Usually it's hidden in the question. And maybe one step involves rationalization or something of that sort. Is this clear?
Yes, sir.
Moving forward, let's look at how do we do an addition and subtraction of surds. Because we've seen how powers are added and subtracted. Now let's see how to do addition and subtraction of some surds. Now, I always say one thing that whenever we say how to add or subtract surds is that treat surds as variables. What do I mean by that? Let's see. Consider an example. Hmm, Any example would suffice, like 4 under root 3 plus 5 under root 3. Okay. Now, if I were to treat this as a variable, let's just ignore the surd for the time being. Ignore that. Forget that there was anything ever there. If I ignore this and simply replace it with, let's just say that, I replace it with x, a variable, and continuing on, let's just say 5x. What would my answer have been? If my two variables are the same, this is like just probably the easiest question I'll ever give, which is 4x plus 5x is equal to 9x. Clear? Keeping this in mind, now you're forget about the fact that you're using. Just give me a moment, guys. Just a moment. Uh, Now, treating the third as the variable, what's going to happen? I was treating your third as your variable. Now let's forget about this. Treat it as the variable itself. Now, if I treat it as the variable itself, what's going to happen? Your coefficient is being added, and your variable or your third, which are being treated the same way, are being kept as it is. Is this clear, guys? It's the same thing as always, but there's a slight catch. How do you determine which two surds are equal to each other and which two variables? Because variables, it's easier to understand. X is different from y, x is similar to x. You can easily add, subtract, whatever. But let's just say that, 2 under root 2 minus 2 under root 3. Now, even if we've seen this with variables as well, that even if there's a slightest change, like for example, this is 2x, and let's just say that this is 2y, what is going to happen? The final answer will be 2x minus 2y. Obviously, you cannot add or subtract them together. You cannot simplify them further than than their current position. Why? Because you can only add up like variables. What will happen next? If I consider that with the third, it's going to remain the same thing. Why is that the case? Because these two are not equal. Your base over which the third is acting is a part of your third. So if the base is dissimilar to your third, your power is also going to be your entire third is going to be different from the other. Keeping this in mind, we'll continue this as 2 under root 2 minus 2 under root 3. Now, another scenario could be, I'll take the same example. But this time around, what I'll do is that instead of what you may call, I'll take the base even same, but the difference I'll do is I'll take this as cube root. Now, if this were variables, obviously, this would have been like x. And if there's a power on x, this would have been like x cubed or something like that. Can I subtract them together or add them together? No, I cannot. I'll have to leave it as it is. The same goes with the third as well. So they need to be identical. Your surds need to be identical for them to be they're simply just treated like variables. Exactly how you would treat add or subtract a variable, you would treat your surd the same way as well. So it's going to be 2 under root 2 minus 2 under cube root 2. Any questions regarding this? Hopefully this is clear. Simply moving on with this. Now what's going to happen is that the same way we treated your surds and addition and subtraction, you're supposed to more or less do the same thing with in division and multiplication as well. So multiplication and division. How you're going to do that is that simply you're going to treat your surds as variables. How am I going to do that? Oh, get you back there. Yes. So we're going to treat surds as variables. Let's look at a few generic examples. If you have this and they're being multiplied to, like, let's just say x under root y, and this is multiplication sign under root y. Your final answer is going to resemble this. You can group them all together. They're acting under the same surd, right? You can group them all together. Similar is the case with division. If I were to divide this, if I were to divide this with each other, again, you can simply a over x is going to remain the same. Take whole root. Now, why is that happening? Because, for example, if you had x square and you were multiplying it with x square, can you not like take them completely or something of that? Like, for example, if you have, let's just say that x square times y square, can I not write them or can I not factorize them as xy whole square? I can. Therefore, I can simply group my unlike surds together as well and put them under one sort of, you can say, one surd, if that's the case. If they're equal to one another. If they're not, then obviously that is not going to work at as well. Is this clear? Make sure that you know your like, for example, if x times y is xy, then x squared times y squared can also be written as whole xy squared. Same thing. Not much of a difference at all. So in multiplication and division as well, your surds are always going to be treated as variables. There's nothing going to change. You already know that if two surds are identical to each other, their answer is equal to their base. We already know that. We've done that over here in rationalization. If two surds are identical to each other and they're being multiplied, their answer is the base. We already know this. Like, for example, if it's under root a times under root a, the answer is a. We know that already. We don't need to go into the depth of it. Clear, guys? Now, let's move forward. Let's see what happens when you have a fraction in your denominator. Like, for example, but the numerator of that fraction is not equal to 1. Like, for example, let's say a raised to the power x over y. Now, you have a numerator which is not equal to 1. Why is this different from when we started off surds and we said that you know how to change into index form and surd form? Is that you guys notice is that whatever surd form it was, when it was written as an index form, you took your power, the numerator of your power is equal to 1. But what if, let's say, that it's not equal to 1? Let's just say that you know it's not equal to 1. So now there are two possibilities of what can happen. First up is technically what is happening. Let's just say, see what is happening. First off, you have a raised to the power x, which is happening. And then next off, you have a raised to the power, what you may call 1 over y, that's happening, right? These were the two possibilities that we were taught with, which is going to be your um, root of y with base a. These are the two possibilities that we were taught, but now they have come together. They have joined forces. What has happened now is that simply what I'm going to do is that I'll take this down and I can do this in two ways as well now. What are my two ways? Let's see. The first way is that I consider this on the inside and 1 over y on the outside. Right? Because these were the two ways I was taught. This was not something I was taught. So I'll just break it down. Obviously, a raised to the power x times 1 over y is equal to x over y. When you multiply it with this fraction, obviously that's going to happen to the power. Considering this power, the first thing that is happening to the power is what? That you're taking the power of a as x, and on the outside, the whole power is that you're also taking under root, so you can solve it like this. First, take the individual power and then take whatever respective square root it has. Oh, under root it has. Secondly, what could be another option? You could take 1 over y inside, take x on the outside. What will that do? Is now you will just have to take under root of x, the base first, and then take whole power of it. So it depends on your question, it depends on what you're comfortable with, and it depends on what is accessible at the moment. Both of these ways are perfectly correct. Keeping this in mind, there is one last sort of like limited, very easy property that is left before I let you guys go, which is what if you have numbers inside which are not perfect squares? Like, for example, consider an example. I think I did this in my class. I don't think it was you guys though. 3 under root 12 under square root plus under root 75. And this is a past paper question, by the way. I think it came like paper 2 a while ago, though. It's an older question. What will you do? We know for sure that these both are not perfect squares or perfect cubes, whatever it is. What you're simply going to do is that we know that if two things have the same, if two bases, even if two different bases, if they have the same surd on top of them, you can write them together, or you can write them together and multiply them. So I can easily break these numbers bases down into numbers which are actually perfect squares or perfect cubes, depends on what the root is. So over here in this instance, it's going to be perfect squares. So can I not break this down as 3 under root 4 times 3 under root 3 plus under root 75? 75 can be broken down into 25 and 3. Now, the reason why I did not break 12 down into 6 and 2, and 75 into probably like, 15 and I don't know, like 5, 15 and 5, is because 6 and 2 and 15 and 5 are not going to help us out any bit because they're not perfect squares either. 4 and 25 are still perfect squares. Now what's going to happen? A bit of properties of indices are going to be, surds are going to be used. Because if two things are being multiplied together and they have the same under root, you can write them together or you can even write them separately. I can write them down like this. There is no restriction on me. Whatever can happen one way can happen the other as well. And over here, I can do it like this as well. Clear? Now, what's going to happen? 3 as it is, under root 4 becomes 2, and under root 3 is not solvable. You can write it as it is. On the other end, it's going to become 5 under root 3. Now, solve this as well further. So this is going to be 6 under root 3 plus 5 under root 3. Your again now the first rule of the addition rule of indices surds comes into play, that you have to treat them as variables. So if the surds themselves are perfectly identical to each other, what's going to happen is that you will just add up your coefficients, add, subtract, or whatever it was. So it's going to be, your final answer is going to look like 6 plus 5 is 11 under root 3. Clear? Any issues with this? Anyone, if anyone has any issues? All right. Hopefully this is clear. This was just an example question as to when and if you get some sort of question in which they ask you to simplify it, but the number inside the under root is not a perfect square, cube, or whatever it was. So you can simply just cut them down into two numbers or break them down into two numbers, which when they're multiplied, mind you, make sure that you're breaking them down into two numbers which are multiplied together. Okay, do not go for addition, subtraction, or something of that sort. And make sure that you're breaking them down into two numbers which are multiplied together. And one of those numbers at least can be what you may call is a perfect square or a perfect cube, depends on what your question is. And now look at the question itself. Seemingly something looking like this was now written like this. So, Saad, this is to answer your question that what happened. This is a more conventional type of a question. This is the question that the examiner really likes to ask. So he does do that in paper two as well. And now your paper two is also without calculator. So these type of questions can, pop up anytime. Having said all that, if there's any questions, let me know. Is there anything anyone doesn't get? Let me know. Yes.
So is there a major difference between questions in paper 4 and questions in paper 2?
Not a very major difference. Like the biggest difference that I would say is the fact that obviously questions will be quite calculator oriented and non-calculator oriented. So you will notice the difference. Bigger values will be excluded. Decimals will, they won't have a lot of focus on decimals. I have noticed that the projection that we're looking for, and I've noticed this, is that this is just from my opinion, is that I think that personally paper 2 is going to be more algebra centric, and questions which involve lesser of a working than paper 4. And obviously, paper 4, we have seen this trend is that, paper 2, relatively, the questions are smaller in marks as well. Like the marks of questions in paper 2 are lesser, but now they've also equaled the percentage. So that's not probably not going to be an issue. But usually we've seen is that paper 4 questions they require multiple steps and they can even go up to 6, 7 marks as well. Whereas I don't think, obviously, we've been following the old syllabus. This is the first time that you guys will be giving the new syllabus. But I've never seen a question in paper two which has been, a very multiple step question or it's very difficult. Usually it's like small questions, short structured questions with like 2, 3 marks, 5 marks, 6 marks at max. But paper four is usually, like there's multiple parts to each questions and stuff of that sort. So that is the major difference. When we go through with past paper practice, you guys will notice the difference. There's a like the clear difference. In paper, what you may call four, you'll notice that the values that are given to you are a bit different. Even if the question is identical to each other, the values will be different because it's calculator centric, right? Obviously, he's not going to give you like 2 plus 3 in a calculator paper. He's, the questions given to you will be those that are going to require the calculator because one part of your syllabus says, and it's one of your, learning outcomes as well, that the ability to, use and handle the calculator. So, yes. Any other question from anyone? If not, keep smiling, guys. And whosoever have not joined the Google Classroom, please send me your functional emails so that I can make you join. Nonetheless, we'll continue this tomorrow, guys. Keep smiling, run off, Allah Hafiz. Allah Hafiz.
Sir,
Well,
I've sent my
Love is
email in the chat box.
Zoya, you've sent it in the chat box. Zoya, do you have a class after this?
No.
All right, Zoya, could you just give me like 2 minutes? I'll send you the invite in front of you so that you can tell me if you've, received it or not, because sometimes Google Classroom glitches or something of that sort happen. So I've sent you the invite. Could you kindly check?
Yeah, I've received it.
All right, Zoya. Let me know if it doesn't work. Let me know. All right, Allah Hafiz.
Allah Hafiz.